Hey guys, we're going to be looking at part 2 of the Regents review guide. And again, if you're not one of my students, you can purchase this at Teachers Pay Teachers. Definitely will help with preparing for that New York State Common Core algebra test. And part 1 we did the first 5 sections. Okay, so that was part 1. And today what we're going to do is we're going to look at creating equations up to transforming functions. So there'll be a few other parts that are going to be coming shortly in the next couple days. Like I said, feel free to use these to help you review. So let's go to page 11. Start with creating equations. And there's tons, usually at least a few different equations that you have to create for multiple choice short answers. Most of the time they do a linear, sometimes exponential. And this will just kind of go through some of the basic ones. So the first thing you want to do, kind of like I put up at the top, is you want to figure out what you're trying to find the value of. It's very clear, read the question. It says right here, how many miles does Mrs. Klein drive? So like in this case, I'm going to use M for miles. And you can write it out, define it. That's what the whole purpose is. And it says to rent a car, charge $75 per day and 5 cents a mile. So because the 0.05 represents miles, we're going to put those two, the 0.05 and the M together. Okay. It's $75 a day for the car rental. We want to figure out how many miles she drove if she rented the car and the total cost was $92.40. So again, this is just a one variable equation, and your goal here would be to get M by itself. Okay. And in the case if they didn't give us that total, then we'd have a linear function that would be graphable, give us different amounts. Okay. So that's kind of what we want to focus on in this section. So we'll move on. Go into the next section. Okay. Once in a while you catch a consecutive integer question. Okay. And consecutive integers are just one after the other. So 3 consecutive integers could be like 3, 4, and 5. Sometimes they'll do consecutive even. So that would be like 2, 4, and 6. And odd, like 1, 3, and 5 also. And with the first question, we're just going to set that one up. It says find 3 consecutive integers where the sum of twice the first and the third is 29. So the 3 consecutive integers would be x, x plus 1, and x plus 2. Because that's what you would do to get the next one. So sum of twice the first. So this was our first one. X is the first one. X plus 1 is our second number. X plus 2 is our third. So twice the first would be 2x. 2 times x. And the third is 29. So and the third, we're going to add that together. It says sum. Okay. And again, it's just putting those pieces together. So you could combine like terms and solve for x. You don't really need to do much with the parentheses. There's nothing before it to distribute it. So I'm just going to rewrite it without the parentheses. Combine these like terms. 2x and 1x is 3x. And then get x by itself, subtract 2 on both sides. You get 3x is 27. Excuse me. And divide by 3 and you get 9 for x. So that means the 3 numbers would be 9, 10, and 11. So pretty similar with the other ones, try to make sure you set it up correctly. That's the biggest thing. So let's move on to interpreting graphs and functions. And the focus on these questions would be definitely to understand what the question's about. Okay. So he's a local pizza boy, Andrew, and talking about the deliveries he made. So you want to focus on what the variables mean. So time is the x variable, and then in this case the distance from the store is a y variable. So he's making, in this case, he's going farther away. There's a little break for about a minute, and then there's a 4-minute break. And the goal here is to think about what this could mean. So he's driving, like this part here could mean that he's at a light. If he's stopped, he's not gaining any distance. This part could be where he dropped off the pizza. And then he's driving back here, but again, he hits another light. Maybe he hits a light or a stop sign, traffic, anything. But it's all about, interpreting what the question's about. So those are the kind of things you want to look at with these graphs. And then the slanted lines represent, his speed, his rate. How quick is he going? Now, with questions like 5, 6, 7, and 8, talks about Jenna selling items. They give you an equation. We have two variables. We have x. Again, looking at the table for what they represent, the number of scarves, and that's the cost. So, if she sells one scarf, which they want you to type right in the table, you got 4 times 1 plus 20. So in this case, that'd be $24 the cost. So you could use the table to help you with, after you fill it out, help you with the next few questions. Then we talk a little bit about some function notation. So there's a graph, and then it comes with some questions. And we go through some of the important vocab you'll run into, like roots. Roots and zeros are the same thing, where you touch the x-axis at. So like we have a root. There's one root, there's a 0. Okay. If you have to evaluate, use the graph. So like if you're evaluating f of 2, you would go to where on the x-axis where 2 is, and the answer will be based on how far up or down, how many spaces you have to go. And the last part we're going to talk about would be function notation. So the idea of what is a function. Now here's the pretty much the gist of a function. A function itself would have to have one, like it says here, each domain value only goes to one range value. So let's say I went around and I bought people hats, and it cost me $5 for a hat. By an equation like this. We know one hat costs $5. We would know 2 hats cost $10. We would know 3 hats cost $15. We would know 10 hats cost $50. Okay? This is a function. It's a linear function because there's only one answer you can get. Now, if one hat cost me $5, and then someone came along and said, oh, I got one hat, but I got it for $7. Right there, that wouldn't make sense. So that's what the focus is with a function. Okay? You should only get one answer out for one answer in. So, hope that helps with the function questions. Okay, you'll see some of those there. And then the last part we're going to look at is transforming functions. And you'll see up at the top it talks about the shift, which directions it would shift. So if you look at like the first example, f of x minus 6, well that would be similar to this one. So that would mean that this function would shift down 6. So every point would go down 6 based on that. And then with the quadratic function, our focus on A, B, and C is what happens from the original one. So if you were to graph x squared in the y equals section, how do those change? And usually the words that they're looking for on the Regents are wider, narrower, and then also, does it flip? Is it flipped at all? Okay. So make sure you use those descriptors when you're doing this question. And thanks for watching. Good luck. Good luck.